I don't get an introduction?
I'm coming.
All right.
Okay, just wait for me. I'm getting older. So, everybody, it's my pleasure to introduce Travis Dillard, who's working on a project that has been near and dear to my heart and is going to be, I believe, used, I expect to be used, by CS1 in the next year going forward. Travis.
Thank you. Thank you. My name is Travis Dillard, and I will be presenting my, maybe not yet, if this thing doesn't.
The center button.
Come to me. There we go. Presenting my senior capstone titled Fair Computing. So, the problem that I'm trying to solve is that students should not be required to have an expensive computer in order to write, test, and debug their code at a high speed. I think it's safe to say that the computer science department here at Carthage would hate to have any student drop or choose not to pursue a CS degree or major due to financial reasons, leaving them with inadequate hardware. There are also inconsistencies among operating systems. For example, Windows primarily uses Visual Studio for their IDE, whereas macOS uses Xcode. Although Visual Studio is available for macOS, it isn't quite the same, and Xcode is primarily used for developing in Cocoa and cannot handle C and C++ as well, which is what we primarily develop with, specifically in the CS1 and 2 classes. This makes it difficult for the instructor to debug and teach their students when there is a mixed bag of IDEs because of the steps and features on one are not mirrored in the other. A solution to this problem is the one that we currently use, a virtual machine, so that everyone is on the same playing field using the same IDE that provides the same interface and features for every user. However, not all students' computers can run virtual machines well because they're very taxing on the computer's hardware. So running a virtual machine on top of their normal machine will cause a slow development process. So it seems like right now we have solutions to each individual problem, but each solution interferes with one another. So as of now, it appears the instructors have to make a conscious choice between a uniform developing environment or a developing environment that is native to users and runs well on student machines. That's where fair computing comes into play. Fair computing is an attempt to give instructors and students a tool that will allow students to develop in a platform-agnostic environment without the need of expensive equipment. It is designed for student code to be developed and linted locally on their native environments, but compiled, saved, and debugged remotely on a Linux server with many layers of extraction to hide the process. So I've accomplished this task by using Visual Studio Code as the user's front end because it is very lightweight, highly extensible, platform agnostic, and coincidentally uses the GDB. The back end will be a Linux server due to its high performance. And Fair Computing will also provide a source of backup on the Linux server in case a student loses their laptop or it becomes damaged. So this is the flow of the control from the student's perspective. The students will launch the desktop client once and only once, and then follow the prompts to create an account on the Linux server. Let's see if this works. Ooh, there we go. So they'll run it once, connect to the Linux server, and then from there, they will never need to run the client again. From here, all the users will be required to do is open Visual Studio Code. These are my students here. And launch the Fair Computing extension. If any of you have taken the OOP course or are currently in the OOP course, it is the equivalent of launching the Maven Java extension where it pre-compiles a whole Java project for you. When the user launches, or the student launches the Fair Computing extension, they will be prompted for their username and the name of the desired project folder. The extension then creates a pre-configured Hello World project folder, and then the students will be able to freely develop it from there. Every request to compile, run, or debug is sent from the user to the server, and then it is done there, and the results are sent back as plain text where they will be displayed in the terminal. So all files are sent to the server, which is attached to this network attached storage, and that will be acting as our source of secure backup. So there are four main components to my Capstone. They are the desktop client, the Visual Studio Code extension, Fair Computing, which allows the remote debugging, file transfer, compiling, and execution of student code, the Linux server to execute all of the requests sent by the extension, and the network attached storage to store the student files and provide a secure source of backup. So the first part is the desktop client, and it is a C++ executable that will only be needed to run once per student for their entire time at Carthage. And the client creates an account on the backend Linux server with the user inputted credentials. The client also creates an SSH key for the user to have a passwordless SSH experience. This will mean that the student, every time the student makes a request to build, debug, file transfer, or execute code, they will not be required to enter in any passwords, giving the impression that it is all done locally. Some of the must-haves for the Windows users, unfortunately, you will need to install PuTTY. PuTTY is a free SSH client that allows for SSH and file transfer on the Windows platform. SSH is a way of operating networking services securely over an unsecured network, SSH standing for Secure Shell. And the users will also need to install Ubuntu from the Windows Store because the client requires a bash shell to run. I'll explain that later, why. And for macOS and Linux, the only thing that you'll have that is different from Windows is you will need a library, SSH pass, required in order to fully automate the transfer of the SSH key on both of these platforms. And then the must-haves for both platforms is Visual Studio Code, the Fair Computing extension, and 3 third-party extensions as well. The first one being Wiximomo for transferring files onto the remote server, WebFreak for the permission to remote debug over SSH, and CPP tools by Microsoft for linting and IntelliSense of C and C++ in the Visual Studio Code editor. And linting are those nice red and green squiggles that you see that allow you to catch your mistakes as you type them. So now I will go into a demo. And this terminal right now is my account on the Linux server where I will kind of flip in between backend and front end as proof that I'm creating these things as I'm using the extension. So first, we go into the student directory and we notice that there are no students. So we go over to the bash shell on my computer where all the students will have open and they will run the client. And from here, they will need to enter their Carthage email twice to ensure that they entered it correctly. And if they mismatch, it will prompt you to enter them again, both. And then it'll ask you to create a password. I know the password, it sounds funny that I'm bringing this up because it's supposed to be a passwordless environment. The reasoning for this is if you do lose your machine, you will not have the same passwordless experience until you create another SSH key. And in order to access your files, you can still do so by using this password. So, it looks like you're not typing anything, but I imagine this will be used in class where a lot of your peers are around. So to add a little extra barrier of security, I wanted to hide all of the user input so they don't see what you're entering in. And after they hit enter, you can see the SSH key being created and transferred over. And then I go back to the Linux server, I list the contents, and you see that the user was created. So from here, you will not need the client whatsoever. Here, I go into the students directory, and we see that the directory is empty. So now, this would be the part where you open Visual Studio Code, and you launch the Fair Computing extension. I had shouted out the Maven project. That's because from my OOP class, I use it frequently, so it showed up in the little cache directory there. But you execute Fair Computing. It asks you for the username. Enter in the username, and then the desired project name. And then we see here that it was created. I have it set to automatically create the folder on your desktop in order to increase accessibility. From that point, you can move the folder wherever you'd like to. I just don't want users digging in through their file system to find this created folder. And from there, you open the folder. Ignore my snapshots. And you see the stub C++ precompiled program. Now currently, this is not on the Linux server. In order to get it onto the server, we need to make a change and save it. So I click at the end, I add a space, and save. And now I go onto the back end to show that the project is actually there. I go into the project, and it overwrote carriages are fun. And then that is the exact same program that was shown in the extension. So, now, at this point, if we list the contents, we only see the main file. We cannot currently execute this code because C++ programs need to have a binary to kind of execute. So that was my proof of saying that it doesn't exist. And now in Visual Studio Code, there is a shortcut. As you can see, I added on the top, Control-Shift-B to build or compile your program. So I do that. We see that it is compiled. We go back over to the back end, list the contents, and there's the executable. And we execute the binary, and we see the hello world, the expected output. However, that's not the goal of the project, or the capstone. We do not want to have the students kind of jump in between creating a binary and executing it on the server. So I will also demo that you can execute that binary from Visual Studio here. And then that's the same running executable. All of this was executed on the server and sent back as plain text that you see there. And my apologies for the little watermark. I didn't want to pay for software. Sorry. So now I will demonstrate remote debugging. I add a for loop. I will recompile to get the change over into the binary. And then I'll go to the debug console and click VS Code's nice and handy debug, start debugging. And since there are no problems with the code, it just executes. So I add a breakpoint. I launch it again, and it will actually stop at the breakpoint. And you can see the value of the variables. I don't know if you can see it in the back, but I is initialized at 0, which we had expected. And when I step through the loop, we see that value being changed, as well as the output on the bottom goes to 2, to 3, to 4, and then finally outside of the loop. Now this is all fine and dandy, but we don't always write perfect code. So I wanted to make sure that if there was a bug in our program, that it would catch it remotely. So I add a known bug.
That is a bug.
Try to compile, and then it's actually caught, and that gives you the same instructions that you were to get back on the back-end Linux server on how to fix it. So once I fix the bug, and recompile, and execute, the program is back to its functioning state. Now with a combination of all of these little short snippets, you can develop remotely in its entirety. Currently, I do not know of any features that would prevent you from using this for your full development experience. So I will talk about my capstone advice. Start early, work steadily. You've heard it 1,000 times, and I don't think you would have heard it 1,000 times if there wasn't at least a little bit of truth in there. If you wait too long in between developing sessions, you might forget what you were working on or how something works. Even if you're just reading documentation, any continual progression will not only help you finish faster, but it'll keep your ideas fresh in your head. I'm guilty of this. During J-term, I didn't work on it very much, and when I went back into it at the beginning of the fall or spring semester, I had to a lot of my time was rereading what I had written because I didn't understand it enough to expand on it. And also, don't be afraid to jump out of your comfort zone. You can always take a step or two back if your project is too difficult. You'd rather finish a capstone project and be proud of what you made rather than doing something that at the end you don't feel too proud of or you think it's a little lackluster. Also, solve a problem that you're passionate about because you will be spending a lot of time on your capstone. Make sure it's something that is of interest to you. So, that being said, I had a lot of difficulties in my capstone development. The majority of my obstacles were from the Windows operating system, and I think this face captures my love-hate relationship for the OS at its current state. I was trying to limit the amount of dependencies of the Fair Computing extension in order to have a cleaner distribution, but I was having troubles with sending over credentials due to the lack of SSHing capabilities that Windows has in its default stock. So that's the reasoning for PuTTY. And I was also having issues with sending over files to a specific location on a Linux server from the command line. So PuTTY also helped me accomplish that task. And the reason why the client must be ran from a bash shell provided by the installation of Ubuntu is because I was having a huge issue with the Windows client executing a batch script with elevated privileges that would require 0 user input. I wanted the client to be ran once with no interruptions and have the student not be prompted once. And if I were to do it in Windows, it would have to happen, and I didn't want that. Another problem that I had was with the Visual Studio Code extension API. The documentation for creating an extension and adding cool features are there, but at first it can be hard to follow due to the lack of examples given. However, once you get the feel for the API, you can add to it pretty seamlsley. My biggest piece of advice for creating a Visual Studio Code extension would be to play around with it, add little features here and there until you get the feel for it. But with that, be careful. Make sure you actually write a little, test a little, because with my experience with these extensions, they're fairly easy to break. All right, so future work with Fair Computing would be the addition of Haproxy. Haproxy is an HTTP TCP load balancer, and this would allow me to connect more than one Linux server in order to host more students at once. And the addition of a Haproxy would allow for the backend to grow linearly. For every server you add, you get that many more users. I would also like to add a client graphical user interface. Although the user will only see it once and for a short amount of time, I would still like to provide a user interface that appears to be less primitive. And this is the flow of the control with the addition of a proxy, where the client will still only be ran once, but instead it will be sent to the Haproxy, where it would be distributed to the 3 servers. So the user would have an account, if you will, on all 3 servers, and every request to compile, debug, transfer would go through Haproxy first, and then distributed to the server with the least amount of work being done on it at that time. So in my previous picture, I had front end and back end pretty distinctly defined, whereas now Haproxy kind of acts as that portal into the back end. And all 3 of these servers will still be connected to the network attached storage, so we will not lose the secure backup. And for reflection, I learned a lot. Prior to the capstone, I had no knowledge of batch or bash scripting, automation, or even what Visual Studio Code extensions or workspaces look like or how to develop in them. Linux environment, I strengthened my abilities with that, especially on the command line and transferring files or the information between files and from computer to computer. And I actually use a Berkeley socket outside of networking, and that was pretty neat. At the beginning of the capstone, I didn't think I had the ability to complete it or even come close, but once I started seeing the pieces of the puzzle come together, it inspired me to keep going. Perry had come up to me because I was having a midlife crisis, if you will, about coming up with an idea. I'm not creative. I'm more of a person of tell me what to do rather than I'll tell you what I want to do. And he approached me with this idea, and at first I asked him, do you really think I could do that? That seemed way out of my realm, but he kind of gave me the will to keep going, and thank you for believing in me. So I learned about my personal strengths and weaknesses in software development, so now I feel more prepared to capitalize on what I do know and learn from what I don't. And are there any questions?
What is the limitation, if there are any, for developing without internet connection?
You need an internet connection. The question was, what are the... Oh, sorry, could you repeat the question?
Limitations
Okay.
if you did not have an internet connection.
So if you do not have an internet connection, you could save your file locally, but you could not execute or debug or anything like that using the remote. You need a network connection.
But then if you were to regain that connection, you could then save it, they would send it over to the server.
Yes. Yes. Yes.
This is more a question about the capturing the demo. Have you considered using OBS?
I was thinking about it. That was one of my options between that one or this one. This one was really intuitive. The other one I didn't want to spend time doing because I had planned on doing a live demo until a couple of days ago. And then I realized, wow, there's like 1,001 things I could break. Well, I do it. And I wanted to ensure that I didn't have to worry about any of those kind of issues. But otherwise, I have heard OBS is really good for that.
So you said you need an internet connection. Would there be like a requirement like being on like a Carthage network?
So you don't have to be on the Carthage networks exactly, but if you are off campus, you will be required to be attached to the Carthage network in some way. We do have a VPN here. However, I would be a little worrisome to depend on that because I don't think they want to hand out VPN access like it's candy. So I don't think that problem happens very often. I've been off campus my entire 4 years, and even when I have been in a time where I've needed VPN, I didn't have a problem with just coming to campus and working on it there anyways. So I guess that could be a downfall being a commuter. Any other questions? Yes.
So just this week, Microsoft announced that every new version of Windows will have a Linux kernel. What effect would that, let's say that's true, what effect would that have on the Sphere computing?
So the question was, Microsoft this week had introduced all new versions of Windows having Linux subsystem on them. So it would eliminate the need for users to have to install Ubuntu, and depending on the capabilities of this Linux shell, they would either still need PuTTY for SSHing, or they would then need the SSH pass from the macOS or Linux platforms. So it would actually eliminate some of the Windows dependencies for sure. Are there any other questions? Thank you for coming to my Travis talk.